about it, but let's just talk about basic concept of how we write. Thinking like a programmer, basic concept of on how we write program codes. We need to understand that in order to for us to write a code, set of instruction to perform a specific task, it is very necessary for us to understand the basic syntax, that is the acceptable symbols or characters, and also the semantics. Semantics give meaning to syntax. For example, A plus B is actually a semantics that is defining or describing the acceptable syntax or symbol for writing a program that we add two variable A and B. So understanding the semantics, and also even part of the semantics starts from the proper way of writing a variable or declaring a variable, sorry, the proper way of doing something. And so semantics talk about how the proper way of how these things are being done, while the syntax talk about the actual symbols or characters that are used for what, for doing it, for writing the code. Referring to what we did previous time, the syntax there, we could talk about each of the various syntax, talking about um, the syntax, like syntax for writing the comments, syntax for writing an include file or another file, the syntax for declaring the variable, like using the int, you must have the data type and then the name of the variable. Those are like syntax, each of the same. So when you now declare it very well, when you now declare it in the actual sense, that is what semantic is. For example, when you are against the semantic is when you now do something like probably int a equals int a equals 1 comma int b equals 3. Like this semantic is wrong, because it is not acceptable. This way, the actual way of doing this is not available, because we are trying to say int a equals to int b equals 2. So that's what like semantics means. So acceptable semantic is that, okay, if we are declaring variables in one line, then this int, as long as you have used a comma separator here, it covers all whatever variable that comes on that line. So when you have int a equals 2 comma b equals 2, you are trying to say int a equals 2 comma int b equals 2. So you don't have to do int. So that is just one thing. That's not what we are going to. So semantics. Now we can say syntax is about the form of a code, how the code would look like, while semantic is about the meaning of the code. So when your semantic is against the defined rule of a particular language, then there will be error. There will be semantic error. We have different type of errors in programming. We have syntax error when you use the wrong syntax. We have semantic error when the proper way or the logic you are trying to you to you coin different syntax together is wrong. We have compiler error. We have um, we have user and so on. I just forgot them right now, and I remember them. So all different type of error, semantic error. We have logic error too. Okay. So for example, if we need to create two variable that will hold two different numbers, such that we can later do something with those numbers. To do this, first we need to know the acceptable syntax of that programming language that can allow us to create variables, give or assign values to the variables. We need to understand the acceptable syntax that will allow us to do this. We need to understand give okay that will give us or assign values to the variables, and also allow us to do something with the variables. For example, print out or manipulate them. So that is just one of the things, as being like a programmer and as someone who is about to write programs, you need to really understand. That is why we did that. Our first algorithm pseudocode whereby we defined all of this step. So now, for example, creating a variable in C, we first need to understand which type of variable we need. Okay, is it a number? Is it a string or character? Or is it an array or any of that we have stated before? There are more data types. So one take home from this point one is when we are creating a variable that we want to use to do something to hold a particular value, we need to know what type of value the variable is going to hold. It is by the type of value that the variable is going to hold that will determine the type of variable we are going to create. Okay. So when you are buying clothes, you need to know the person that is going to put on the clothes. Is it a male or a female, or probably an animal or something? So trying to understand that will tend to give us understanding of how to what create the variable, or how to buy the clothes, or which clothes to buy. So, for example, we have already talked that I've even said many of these in the crash when we are having the assignment. If it's a number, we have different type of number. As I said, we have integers or whole numbers. We have floating point numbers, numbers that accept what decimals, fractional part. So we have for a number we have integer. The syntax for this in C int, the type of data which is int, specifying integer, and then the name of the variable. We have done this. Or if it is a character, then the syntax is char, char, and then the name of the variable, which can be defined as type of the variable and what the variable name. So these are just crash because when we still get to variables, we will still really understand. So when we look closely at the codes, we could see each symbols or words that is syntax that describe the creation of a variable in C. Each of these syntax one by one are called tokens, of course. That is, int is a token, even the comma is a token, a is a token, if the assignment symbol operator is a token, and the individual constant numbers are token, the terminator, semicolon, they are all tokens. So these individual symbols are token. That is why when you run a program and let's make an error somewhere, probably I forgot to close this man and I run it. There's going to be an error somewhere. And based on the compiler though, I was expecting that some compiler will tell you error expected token, and they will specify the token. After then they will give you the description. So understanding that every of these symbol individually from the parentheses to whatever is on the screen, they are all tokens. Okay. So we've talked about variables and constant crash like the last time, but let's dive into it. So variables and constants, variables or a variable has a name and a value. So a variable is anything that has a name and value. They are containers or identifiers. That is anything that we can identify with a name. That is why we say variable, they have a name and a value, which has a value. So variables, anything to use to identify a particular thing. So it is you can call it a variable, but and also it must have a name and it must have a value, or the tendency to hold a value. So variables have the tendency to change. So one thing about variables, as based on the name, the word variable comes from what we call vary. It varies. It has tendency to change. That is, can be assigned another value during a program execution. So its current value has a tendency to change in the course of executing the program. So the acceptable ways of writing variables in almost all programming language. This is necessary too, because while we are trying to create variables, probably as we go on in C, there are some there are some some syntax or there are some rules that governs the creation of naming variable. Okay, so we have this conventional system called camel case system, whereby you have the first letter as lowercase, and then if you are merging two words together, the next word that comes becomes a capital letter. Just like you have first name, last name, calc birth year, that's calculate birth year, calculate average, and so on. We have the other one underscore in between variable names, and it's called snake case, where you have something like first name, last name, calculate birth year, and so on. We could have seen all of this in Linux. These are mainly used by mostly Linux users. This the above one is mostly used by JavaScript users and probably PHP. And then we have the other one we call flat case or letter case, where everything is just lowercase, no matter how you you use it. So, but sometimes it said it could confuse when you have longer names. Then we have the other one, uppercase first name, and this one are mostly used sometimes for constants. Okay, so another features of variables can contain numbers, but they must not have spaces. We have, as you can see, it can contain numbers. We can have name 2, name 3, and so on, but they must not have space. Having space, you have separated them. So there are two separators. We have comma separator and space separator. So sometimes when you put comma in between if tokens or syntaxes, you are trying to tell the compiler or the shell or the development environment that you are separating these values, or even if you put space. So variables cannot start with digits. So this is wrong. One name, two calc, and variables cannot have hyphen in between them, just like this. These are just based on overview. When we come to variables in C, creating variables in C and constant, we will see how this really work deeply. So we have constants. Constants also have names and value. They are also containers or identifiers. Okay, anything we can identify them with. So they have name and value constants. But by the name, constant cannot change its value once it is assigned. We call them like constant, they will have to remain the same without changing. So when creating constant, they most times are given special way of creation, which we talked about. You see, uppercase, where you can create constant saying const int pi. Even this is wrong, it's not int, float pi. Okay, so because this is a floating point number. So you can see, and other languages they have different ways you can create their constants. But majority in C, to be specific, is that constants actually start with uppercase. Why are we doing all of this? Is majority for the majority or in among all the beginners, and just to carry everybody along, we could just dive in and start writing all of this, but we just need to get the basic. By tomorrow, we will dive in better. So data types. Now that we know variables and constant, it is now time to understand what we call data type. As we all know that variables or constants are used for storing different types of data, that is numbers, letters, strings, arrays, or objects. It is therefore necessary that we know the different types of data. Okay, we know the different types of data or different data types as far as C programming is concerned. So we we have different data types. Now, one thing that is special that we need to really understand as C is concerned, because when we start it, most of the question that they'll be asking is size of this data type, size of an integer, size of a floating point number in the 64-bit or 32-bit machine, size of a character. Size of data matter very more. They matter very more in C, because C being a language that is closer to the machine level, it focuses more on you defining whatever you define explicitly, that you know what you are doing, and also having making sure that you have understanding of what you want to achieve. If you are creating an application that it requires enough numbers, that's going to be dealing with a larger amount of numbers, then C is expecting you that you use probably double, which has tendency of containing a larger amount of numbers, to what, as the fundamental data type for your numbers. So data types in C language, they have different meaning and they have different amount of space they occupy in the computer memory. So as it being an integer has its own size of memory or amount of memory it occupies. For example, let's just particularize something. I'm going to comment out this logic that we have here. Okay. I'm gonna comment it out. I'm commenting out this one too. So in C, there is an operator called size of operator. Okay, it is used for printing the size of type. You can see expression of type. This is for printing size of different data type in different machine. And now size of data type varies in in machine. Okay, so you can say printf, and you are trying to print size of an integer. I don't really know what methodology this online compiler is using. So I wanted to specify in a 64-bit machine. Obviously, my system is a 64-bit. Okay, so but you can see size of an integer in a 64-bit machine, and you can now say equals, then we do percent %d because we are printing an integer. Okay, there's another operator for integer too. If you don't want to use percent %d, you can say percent %i. So, but we are using percent %d. Okay, so we can do that, and then we reference the size of operator and we put int. So we are referencing that we are printing the size of an integer, and then we close this operation here. Okay, even when we get to data type very well, we have long int, we have short int, we have unsigned int. So this compiler is just trying to ask for too much things. Normally, when you don't specify probably sign, like what you are saying here, when you don't specify sign or unsigned, long or short, automatically it is a sign like this. When you now specify unsigned, then you are actually um being specific. So when you print this now, we should see, you can see size of an integer in a 64-bit machine is given 4 here. I said I don't know the methodology this compiler is. Probably is referencing my machine. So 60 is 4 bits, 4 bytes, sorry, not bits. Okay, so 4 bytes. If I go on and say printf size of a float, now we did just specify sign float or unsigned. We might not know what that means, but when we get there, size of a float in a 64-bit machine So for float, we are referencing f, and then we do, I do not put a new line here, okay, and then add a new line here so that it won't get cluttered. And then we do size of, and then we say size of floats. So right now, this should give me the size of a typical floating point number in a 64-bit machine. Let me copy this and then let's do for double. I'll do for character so that we can have different values because float could be 4 bits too. So let me make this one. Let me make this one character. So a car. And let me make this one this double. So size of a float in a 64-bit machine, size of a car is a 64-bit machine. Now for character, we have to specify the format specifier is %c. This looks strange, but we'll get to know them soon. Then we have size of a float in a 64 in a double in a 64-bit machine. And when we are referencing double, we say long float or LF. So we should see the values. Now, size of an integer in a 64-bit machine, 4 bytes. Size of a float in a 64 bits, giving 0. Okay, this compiler. Okay, probably there's no need to declare, I don't know. It's A, car B, car C, float P, and double E. Okay, so let's put the value A, float P, C, size of C. So we are referencing the variable we created, okay, and double E. Okay, so size of A, size of B for floats, size of C for character, and size of E. And so obviously it is this compiler. It is this compiler, and I could have opened my code blocks. So I'm just trying to reference that each data type they have their value, that the amount of space that they occupy. So data type tells you the type of data you want to store in memory. Maybe you want to store a number, integer, decimal, or maybe you want to store a string or a character. So when data types are specified, the compiler reserves the required amount of bytes needed to store that data, type in memory. So compiler focuses more on the amount of space in bytes. A byte is actually um, a byte is 8 bits. I will try as much as possible. We have a section on number system. This is very necessary, especially when we get to bit manipulation in C, where you have to do bitwise operator. You do left shift, right shift, and left or bit or X or and so on. All these things, there are formulas for calculating them and they are necessary. Okay. So why do we have data type? To know the type of data to store in memory, and also so that the compiler can know how many space to reserve. So types of data type. We have basically um, three types of data type. We have primary data type, we have derived data type, and then we have user defined data type. So primary data type, what we call it built-in, which we have int, float, char, double, and void. And then we have derived data type where we have array, structure, union, pointers, okay, and user defined. We have type def and enumerate or enum. All of these things are things that we are going to come and practicalize with. But what matters most before practicalizing anything, you need to know that thing that it exists, and you need to have understanding of what category it belongs, what function it performs, or what it does. That is why we are talking about data type and trying to speak about it. So this is just what we have for this for today as